Hello everyone, so this time I am solving creating strings, another problem from the CSES problem set. And so let's read the problem statement. Given a string, your task is to generate all different strings that can be created using its characters. So like generating all of its permutations. The only input line has a string of length n. Each character is between A to Z. Okay. So all of the lowercase characters. First, print an integer k, the number of strings. Okay, so I wonder if this includes the original string. And then print k lines, the strings in alphabetical order. Okay, so they're lexographical ordering. So, okay, so I guess, okay, the original string is included in the result. Okay, so nothing much to explain here. Hmm. Okay, so I think this can be done using recursion and for loop, but I wonder if that will give a time limit exceeded. But, okay, let's first try the brute force approach. So, let's use the rocket. Basically, we obviously know so sorry, not it. String s and c in. Okay, good. And for this, I think we should use a set because set will automatically keep things in order, right? There is set of string, and we should name this. What should we name this? This one of the greatest problems in programming. What should I name it? Let's name it answer. And answer dot insert s in and let's create a let's call this helper and then int hmm, how should we go about generating each of these strings? Okay, and my bad. I jumped right into the coding, didn't really explain my approach. So here's what I think. For example, the test case is A, A, B, C. So we can start off by this like iterate over string, pick this character, okay, like pick any one of the character, put it in the front, and then like for example, let's say we are picking B, and then rest of the string will be A, and keep reordering this. We don't have to like worry about the duplicate values because set will only store the unique values, right? So, and then let's say when we pick C, and then generate different permutations of this, right? So that's how we are going to approach this problem. And let's keep int idx. This is to keep track of like which character are we going to pick. Is it this one? Is it this one? Right? Okay, not this, but string prefix, like this part, and then string suffix. this the right way, and we will stop if suffix not empty return. And of course we have to pass in our set. So set of string and percent answer. So for let's end I equals 0, I less than suffix dot size I plus plus. Okay, that is done. Hmm. Student string current will be prefix plus suffix of I, right? Then this like this. Pass this by reference as well because we are creating new ones here, so no need to worry about creating a new one over here. Now, like I have removed the ith character, I have taken the ith character here, so I can safely remove it. So string remaining equal to suffix dot substar 0, comma, 1 plus, right? Hmm. Right, because if okay, actually, no, we have to do this plus suffix dot substar I. You have to start from I plus 1 and then pick up all of the remaining characters. Suffix dot size minus 1, right? Sorry, not minus 1, minus sign minus 1. Let's take an example to be clear. For example, my original string is AABAC, okay, and then my I, let's suppose it's 1. So I want, so it will start from 0 and then it will pick up one character. So that is A, okay. And for the rest of the part, it will start from 1. Okay, it will start from 2 because here we are doing I plus 1. And from here, it will pick up the sizes. Like how is the size? 5, 5 minus 1 minus 1. So it will pick up 3 characters, and that's what we want, right? BAC. So yeah, we will pick up 3 characters. So this will be BAC. Okay. Yes, we are doing it correctly. No issues with that. And so I will also make this out. Okay. Now we need to do helper and name and answer. Okay. We need to do one more thing. Answer dot insert prefix and then we return. Okay. Hmm. Cool. I already know the complex it's going to give a TLE. It's definitely not the most optimal solution. So we need to create a input file, otherwise the input is so small. Let me check for any syntax errors. Sorry, I mean logical errors. So, okay, so I have called it here. Helper. Initial prefix is nothing. Suffix is the original string of answer. And I get it. Let's remove this. So, see out answer size auto it equal to answer dot begin not equal to answer dot end greater plus plus not it and okay and then this is it dereference it and returns okay. Okay, so let's run it. Hit enter. Okay, so it's giving me a warning. Okay, I guess this should have been size underscore t. AC. Yes, guess it works. I think we are generating the right solution. Okay, so it works. I think we don't even need to insert it at the start here. It will still work just as fine. Okay, see, it works. And I already know this is gonna give a TLE, but let's just try it anyways. Yes, I have to make this size underscore t. Size underscore t. Oh, now the warning is gone. Why am I printing the original string? Okay, sorry, my bad. What? Sorry, like no explanations for this. Okay, so I guess we can start with this. Browse. Yes. I already know this is gonna give TL. Like, let's say check it gives a wrong answer on some test case. Accepted? My God. Okay, so I was definitely not expecting this. It's crazy that it got accepted. Okay, so I guess nothing else to do then. Our answer is getting accepted. But I do think there are better approaches to this problem rather than just brute forcing. Actually, I did some research and I must say I'm quite ashamed of my solution. Can I even come with this? So, the optimal way to solve this problem is by using a next permutation function. So, like this, do next underscore permutation. And this function is actually present in this file. Okay, so this function is actually present here in algorithm. So you can actually include this header to directly access this function, but we are gonna implement it ourselves. And what the other thing that there is, this is actually also a lead code question. So as you can see, I've actually solved it before here. I actually solved it quite some time ago today, this date. So this was the solution that I wrote. And as you can see, basically what we do in this function, we generate a lexographically greater permutation of the array. So in this case, instead of the array, we have string, but in this case, we had an array. So as you can see, 1, 2, 3. So the next greater one is 1, 3, 2. So similarly, coming back to this question, we will use a next permutation function and we are going to implement it ourselves. We are not going to use the standard library, the algorithm header, the one provided in the algorithm header. Okay, so while there is a next permutation, we are going to keep calling this function. Okay, so remove this. Actually, no. Let's not modify this. Let me create a new file. We will call it. uh, let's call it optimal. CPP. Okay, and then optimal. Okay. So now let me edit this file. All this will only take the input string s and the set string percent answer. For file, let's call it next string so that it doesn't clash. Underscore greater string. Okay, and this will take in a string. For now, let's just return true and get back to this function first. Okay, so while there exists a next greater string of s, we will keep calling this function and then answer dot insert s, right? And now let's come to implementing this function. So how does this work? So let me open GIMP. The logic for generating the next greatest string, I will explain it here. Um, let's say we have this string A, B, C, and then we have A. So how does finding the next greatest string work for this one? So we'll start traversing from here, okay, from the end of the string, and whenever we find a character that is less than the character on its right hand, for example here, let's check this. C is greater than A, like the ASCII code for C is, I think it is 99, and for A it is 97. Okay, I could be completely wrong, but you get the idea. So 99 is not less than 97. So this is fine. Now we'll move on. And now B. So B is 98. And 98 is less than 97. So this is true. So what we are gonna do, we will swap these two. Okay. So we will swap B with C. So what this becomes A B C. Sorry for my bad drawing. A Okay, this one is even worse. C B A. So this is the result. But you see, this is still not the answer, because what we can do after swapping these two, we need to reverse this half. Okay. So after reversing A, because you see this part is still in increasing order, so we need to make it smaller. That's how we will find the lexicographically greater string. So AACAB. So you see, this is the answer. And even if you check here, task, so okay, this was the answer. AABCA. The answer to this is AA. The next one after this is AACAB. And what we got is AABCA, AABCA, AACAB. So you can see we are getting AA and CAB. So you see we are getting the correct answer. So that's the logic. And this card changes. So now you know how to implement this. So for base, let's return false. Let's make this size underscore p I equal to s dot size minus 2 while I is greater than 0, greater than equal to 0. I don't know what I'm typing, sorry. I is greater than equal to 0 I minus minus, so we are traveling in reverse order. If S of I is less than S of I plus 1. So if it's less than its neighbor, okay, let me check in the constraints. What is the size of the string? Okay, so the size of the string can be 1. Okay, so we will keep a check for that as well. Actually, if it's less than 1, this thing will never even run, so it will return false. Yeah, doesn't matter. If it is less than its neighbor, then we are going to find the next greater one. Okay, the one that is greater than ith character, right? So for int j equal to int size underscore t, j equals 0, not 0, s not size minus 1, j greater than I, j minus minus, j is greater than I. If so I is less than s of j, then we will swap these two, right? Swap s of I with s of j. And once we have swapped them, we will reverse the ordering from s naught begin plus I to s naught end plus I plus 1. Okay, and from here we will return true. Okay, so this looks good to me. Hmm. Actually, we will once we actually if yes, wait, I will just explain. If this part is true, this we will reach here for sure because we will definitely find I something that is greater than I. Why? Because here notice the right character is less than, oh sorry, the right character is greater than s of I. We are here we are trying to find the element that is just greater than I. Okay, so we'll swap it. We will definitely reach here, so we can return to here. And yeah, so this is it. It's done. And one thing that we need to do, we need to sort.